Hey everyone, this is a video lesson that I'm using in my AP Calculus AP class, and I'm putting online in case it would be helpful to others as well. This is the second video lesson for this section, so I should mention that you can find a link to a printable set of guided notes that you can use to follow along with the problems that I go over in this video in the description of the part 1 video for this section. All right, let's jump right back into those notes, and that would be on this page. So we've talked about the fundamental theorem of calculus. We now know it's the most important thing you have ever learned, probably. But we got to get back to business now and talk about the fact that whenever we are finding an integral value, it is finding area. Now, we need to make a distinction in this section between what is called net area and what is called total area. Okay, recall, this is what we've been doing. Net area is whenever you look at area above the x-axis as positive and area below the x-axis as negative. Okay, so we're going to write that. Area above x-axis is positive. Ooh. And area below is negative. Oops, below. And every time you did math 9 in your calculator to calculate an integral value, or you used part 2 of the fundamental theorem of calculus and you found an antiderivative, and then you subbed in the upper limit minus you subbed in the lower limit to find the value of the integral or to find the area, you were doing net area. Okay, but what we need to do here is we need to talk about how do we find total area. And total area is defined as looking at all of the area, no matter if it is above the x-axis or below the x-axis, as positive. So again, total area is all area is positive. And the question is, how do we do that? Because again, math 9 does net area. Fundamental theorem of calculus does net area. So how do we make that area that is below the x-axis become positive? Like, is there something in math? It would be wonderful if we had something that we could use that makes negatives into positives. Do we have anything like that? Yes, we do. It's called absolute value, right? If I look at the absolute value of a function's graph, what that does is it reflects all of the negative y coordinates across the x-axis into positives, but it preserves the area under the curve, or the area between the curve and the x-axis. So you're not changing the amount of area you have here, you're just turning it all into positive. And again, how you do that is with the absolute value of your function. So that's the easiest way to deal with total area, and that is the way that we're mostly going to look at it here in our examples. The one issue is if you do not have a calculator available to you, working with absolute values within an integral is not as fun as just working with integrals. So I will talk you through 2 different ways that you can take a look at it. You can look at example 4 to figure it out. Okay. Find the total area of the region between the curve y equals 4 minus x squared and the x-axis on the interval from 0 to 3. All right, well, let's sketch the graph of y equals 4 minus x squared. We're just going to look at it on the interval from 0 to 3. So 1, 2, 3. Okay, 0 subbed in here is 4. I'm just plotting some points. Oh, I guess I should label. 1, 2, 3, 4. 0, 4. Let's see. How about 1? 1 subbed in here is 3. 1, 3. 2 subbed in for x is 0. And 3 subbed in is negative 5. Okay, so I need some negative y's. 1, 2, 3, 4, 5. Negative 5. Okay, so you can see that our curve goes below the x-axis. Do you like that sound effect? Like that. It shouldn't change concavity. Let me try to keep that all concave down. There we go. And so, we do have a little bit of area that would be counted negative if we were just to set up the integral from 0 to 3 of 4 minus x squared dx and find that value. We are trying to, however, find total area. So we don't want this area to be counted as negative. Okay, one of the ways that you can do it is you can say, well, I know that the integral from 0 to 2 is going to all be counted as positive. And so I can take that area and I can just add onto it the area below the x-axis, but positive. Or in other words, the absolute value of this integral. Okay, and that would look like this. Total area would be equal to the integral from 0 to 2 of 4 minus x squared dx. Let me fix that. Plus the absolute value of the integral from 2 to 3 of 4 minus x squared dx. Notice that the absolute value is on the outside of the integral for something like this, if you're going to approach it like this, because then you can just do what you always do. You can find the answer to this either by getting the antiderivative 4x minus 1/3 x cubed, subbing in upper minus subbing in lower. Same antiderivative here, sub in upper minus sub in lower. It will be negative though, so you will then apply the absolute value and turn it to positive, and then add those two integral values together. Okay, or we could go to Math 9 just to save ourselves some time. And let's see, 4 minus x squared, comma x, comma 0, comma 2, plus the absolute value of Math 9, 4 minus x squared, comma x, comma 2, 3, 2, 3. And 7 2/3, or 23 over 3 is our answer. Okay. There's a weirdness there happening. There we go. All right, so that's one approach. And again, this is the approach you're going to want to take if you don't have your calculator available and you have to use the antiderivative of the function given to get your areas. Okay, but if you do have your calculator available like I just had, really this is more work than it needs to be, because what we could do is we could say, let's look at the absolute value of 4 minus x squared. I'll just look at the whole graph. Okay, there we go. It takes that part of the parabola that was below the x-axis and it reflects it about the x-axis so that that area is now positive. And then instead of using Math 9, I'm just going to go ahead and do Calc 7 to see the shading as well. And you can do the overall interval all at once. 0, enter, 3, enter. Because everything is above the x-axis, and as you can see, we get the same answer, 23 over 3. Okay, so that absolute value of the function reflects for you, puts everything above the x-axis in the positive space, and then you can just calculate it. You can just let the calculator, I should say, do the work. Okay, so how you would write that out, so this is like or. Here's another way to do it. Total area will be equal to the integral from 0 to 3 of the absolute value of 4 minus x squared dx. and we get the same answer. Oh my gosh, did I like write 2/3 up here, or did I just lose my 3? I'm sorry, that should be a 23 over 3. And it's the same thing here, 7 2/3 or 23 over 3. Okay. Now you probably prefer this method, right? Because it is a lot simpler. You don't have to break the interval up. And just to keep this part of our lesson short, I am going to let you use that method, meaning we're all going to have calculator allowed problems here for the rest of these problems in our notes and practice. Okay, so let's pick a different color and do the next one. My 5th period says they like the purple. Not this purple. There's a prettier purple that I can get whenever I like make my own custom colors. And they say pay attention when it's purple. Then they don't always pay attention. Yeah, I'm talking to you guys. Okay, but here we go. Purple, because we like purple. Find the total area of the region between the curve f of x equals sine of x and the x-axis on the interval from 0 to 2 pi. Okay, if you want to pause the video and try this one for yourself, you can. We're just going to go ahead with this method, meaning we're going to find our total area by setting up the integral from 0 to 2 pi of the absolute value of sine of x. I do know that at pi, sine goes below the x-axis. The sine wave goes below the x-axis. So let's put absolute values around it so that it doesn't do that. And then let's go ahead with Calc 7 again. So absolute value of sine x. I'll do zoom 7 this time for the trig viewing window. And then second trace, option number 7, 0, enter, 2 pi, enter. Oh no, something happened. Okay, I figured out what happened, and I should probably tell you what happened in case this ever comes up. I don't know why I've never experienced that before, but it makes sense to me now. Okay, I was trying to integrate over the interval from 0 to 2 pi, and whenever you do zoom 7, a trig viewing window, sometimes your window actually doesn't go completely to 2 pi. So I had an x max here of 6.15, and 2 pi is beyond that, 6.28, right? So what I did was I changed my window to 7 so that I would definitely get to 2 pi so that the calculator, you have to be integrating in your window. So therefore the calculator could do its job, and I lost it, but I can get it back easily. It was 4. The answer was 4. Maybe. There it is. Yay, the answer's 4, which it would make sense if you remember that we said that the integral from 0 to pi is 2. Okay, here you're just adding another 2 on now, so that is 4. All right, so next question is, why do we have this distinction between net area versus total area? Like, what's it for? Why do we need to make area all positive, in some cases? Okay, and the last part of our notes will show that to you. Take a look at example 5 with me. Let v of t equal 49 minus 9.8 t over the interval from 0 to 10. Describe the motion of a particle along an axis measured in centimeters as time is measured in seconds. Okay, we are asked to do 3 things, and they are all going to involve integrals. Part A, calculate the displacement of the particle over the interval from 0 to 7. Part B, if the particle's initial position is at 4 centimeters, find the particle's position at t equals 7. And finally, part C, find the total distance traveled over the interval from 0 to 7. Okay, so if we look at this velocity function, let's graph it. 49 minus 9.8t, it's just linear, but I'm going to go ahead and graph it. Zoom 6, and then I'll change the viewing window from there. Let's have a y max of 50, and we don't need all of that. There we go. Okay, this is what we're dealing with, and you know, what we're trying to do is use areas over these intervals. I guess I don't have I'm like, what's going on here? My Y min needs to be a little bit better. Let's see. Yeah, let's make it -50 as well. Go by tens. Okay, we know that area between the velocity graph and the x-axis gives us distance traveled, right? But what about factoring in negatives? What does that all do? Okay, well, remember, displacement is when we factor in negative motion, okay, into how far the particle has moved. All right, so the displacement would be like your net area. If you are trying to calculate the displacement of the particle over the interval from 0 to 7, you can just set up an integral from 0 to 7 of your velocity function. Put a dt there because we have our velocity in terms of time. And that's going to give you the answer. That's going to give you your displacement. Okay, now again, just to keep it simple, let's go ahead and, I was there. I might as well just use Calc 7 again. 0 to 7. Okay, so 102.9. Let me check my answer key just to be sure. Yeah, that's good. Okay, so all of this is your positive movement. This is your negative movement, and that's going to give you your net movement or your displacement of 102.9 centimeters. Okay, now that actually might not be where the particle is on the axis at that moment. Okay, that's just how it moved. Okay, it moved 102.9 centimeters in the positive direction. So take a look at part B. If the particle's initial position is at 4 centimeters, find the particle's position at 7 seconds. Okay, now that we know that the initial position was at 4 centimeters, we can say what the position of the particle is. The position of the particle is going to come from the expression 4 plus this integral from 0 to 7. So we already know that the answer to this integral is 102.9. Add 4 to that, we now have 106.9 centimeters. Okay, that's all still using net area. But finally, take a look at part C. Find the total distance traveled over the interval from 0 to 7. This 102.9 centimeters, it's factoring in that positive travel, but then taking away that negative travel. Okay, but how far did it travel in all? That would be our total area. The total distance traveled is where we are going to need to set up the integral from 0 to 7 of the absolute value of 49 minus 9.8t dt. And we will be able to calculate our total distance from there. So I'm going to insert absolute values around our function. It reflects for us, and we can do a Calc 7 again. So it takes that negative motion and turns it into positive, and the total distance traveled over that time interval is 142.09 centimeters. I don't know why it keeps doing that, but I don't know if you can tell, but I'm very frustrated with it. I'm really annoyed. Okay, 142.09 centimeters. Final answer for total distance traveled. Okay, everybody, as usual, I hope this was helpful. Bye.